In 1969, humanity reached the moon using less computing power than a modern calculator. Today, NASA has supercomputers, reusable rockets, and half a century of engineering progress. So why has it taken over 50 years to go back? Because landing astronauts on the moon in 2026 is not a repeat of Apollo, it's something far more complicated. This time, NASA isn't just visiting, they're trying to stay. And to do that, they have to solve one of the most complex spaceflight plans ever attempted, a choreography of multiple spacecraft, multiple launches, a space station orbiting the moon, and a lander that never even launches from Earth. Tonight, we're going to follow the exact journey an Artemis astronaut will take step by step from Earth to the lunar surface. And if you enjoy cinematic space documentaries like this, consider subscribing. This channel is a long-form storytelling project about real missions and the future of human exploration. Now let's leave Earth. Everything begins in Florida. At Kennedy Space Center, NASA prepares the most powerful rocket it has ever built, the Space Launch System, or SLS. It looks familiar because it's supposed to. NASA deliberately designed SLS using parts derived from the space shuttle, its engines, its boosters, even manufacturing techniques, not because they lack imagination, but because astronauts don't fly on imagination. They fly on reliability. The SLS produces more thrust than the Saturn V that launched Apollo. When it ignites, the ground literally shakes miles away. Inside the Orion spacecraft, 4 astronauts sit on top of 2,600 tons of fuel. They are not heading directly to the moon, not yet. First, they must leave Earth properly. After liftoff, SLS accelerates to over 28,000 kilometers per hour, fast enough to escape Earth's gravity entirely. About 8 minutes after launch, the main engines shut down. Silence. They are already in space, but they are not going around Earth, they are falling away from it. The Orion spacecraft separates from the rocket and deploys its solar panels. For the first time since Apollo, humans are in a true deep space spacecraft. The International Space Station is only about 400 kilometers above Earth. Orion travels nearly 1,000 times farther. Over the next several days, a carefully timed engine burn sends the crew into a trajectory called a translunar injection. This is not a straight line. The astronauts are essentially being thrown toward a point where the moon will be, and then Earth begins to shrink. The blue oceans fade, the continents blur. Within days, Earth becomes a marble hanging in blackness. The crew now enters deep space, a place humans have not inhabited since 1972. But unlike Apollo, they are not going to land, because the lander they need isn't with them. Instead of descending directly to the surface, Orion travels to a small station orbiting the moon. It's called Gateway. Think of Gateway as a pit stop in deep space. It follows a special orbit, a near rectilinear halo orbit, which sounds complicated, but its purpose is simple. It stays close enough to the moon to reach it, but far enough to remain stable with very little fuel. Apollo astronauts had to bring everything with them in one launch. Artemis astronauts don't. Gateway acts as a staging area, cargo can be delivered separately, supplies can wait there, future missions won't need a giant rocket every time. And most importantly, the lunar lander is already waiting. The spacecraft that will land astronauts on the moon is unlike anything NASA has ever used. It's a modified SpaceX Starship called the Human Landing System. And here's the strange part. The astronauts never launch inside it. Instead, the lander launches separately from Earth, uncrewed, months earlier. Then it is refueled in orbit by multiple tanker spacecraft, a process never before attempted at this scale. Why? Because landing on the moon requires enormous fuel. Apollo's lunar module was tiny because it could only support 2 astronauts for a few days. Artemis aims for longer stays, heavier equipment, and eventually a permanent base. Once refueled, the Starship lander travels to lunar orbit and docks to Gateway, waiting silently for its crew. When Orion arrives, the astronauts transfer across. For the first time in history, humans will board a spacecraft that was launched without them. Now the real mission begins. The destination is not the place Apollo went. Artemis is targeting the lunar South Pole. This region is extremely dangerous. The sun sits low on the horizon, casting long shadows across massive craters. Temperatures swing from boiling hot to colder than Antarctica. But inside permanently shadowed craters lies something priceless. Water ice. Water means oxygen, oxygen means breathable air, and hydrogen from water can be turned into rocket fuel. In other words, the moon could become a refueling station for Mars missions. As the lander descends, it cannot rely on GPS. There are no satellites. Instead, it uses terrain relative navigation, comparing real-time camera images to onboard maps. The engines slow the fall. Dust explodes outward in slow motion, and then humanity returns to the moon. The astronauts won't just plant a flag. They will deploy experiments, test new spacesuits, and explore permanently shadowed regions never seen by sunlight for billions of years. They will test mobility rovers, drill into the regolith, search for usable ice. Every step is practice for something much larger, because Artemis is not the final destination, it's the rehearsal. Everything NASA learns here, radiation exposure, long-term habitats, resource extraction, is preparation for Mars. The moon is close enough to rescue astronauts if something goes wrong. Mars isn't. After about a week on the surface, the astronauts launch back into lunar orbit, return to Gateway, and reboard Orion. The Starship lander stays behind. Future crews will reuse it. Orion performs a burn toward Earth. For 3 days, the crew falls home. As they approach the atmosphere, Orion hits it at 40,000 kilometers per hour. The capsule skips off the atmosphere once, like a stone on water to bleed off heat, then re-enters fully. Plasma surrounds the spacecraft. Communications black out, and finally, parachutes deploy over the Pacific Ocean. Splashdown. Humans are back from the moon, but this time they're not leaving for another 50 years. They're coming back again and again. Because Artemis isn't a mission, it's the beginning of a permanent human presence beyond Earth. If you want to follow humanity's real path to Mars, subscribe to Dr. Malcolm. This channel isn't about science fiction, it's about what is actually going to happen in your lifetime. And in the next episode, we'll look at the one problem NASA still hasn't solved: how astronauts survive deep space radiation on the journey to Mars.